So last class, we were discussing about serial communication. What is the use of serial communication, how it is being used. So today, we will see how we can establish serial communication in specific to 8051. So when I say serial communication, first objective is to achieve baud rate. That means how fast we can transmit the data. So there are two things. One is baud rate and data rate. So as you know, in a serial communication, we will have header like start bit. We'll have then 8 bit of data, followed by parity and stop bit. So only the data at which we can transmit per second, that is the data rate, the data alone. So along with data as well as this header, we call it as a baud rate. So in order to achieve this baud rate in 8051 UART, UART means universal asynchronous receiver and transmitter. So in UART, basically we use timers. Timers are used for using this and for achieving this baud rate. That internally means for generating the clock. So in specific, we use timer 1 of 8050. So as we know, I mean, in one of the session I had shown you how this machine cycle and clock cycle relates. So we know whatever the clock frequency, that is like, 8051, from externally, the clock is derived from crystal. The frequency of the crystal is 11.0592 megahertz. Mega means 10 to the power 6 hertz. So this is given as this clock is given as the input to 8051. So in 8051 internally, we divide this clock by 12. Divide by 12. So when I divide this clock by 12, we get 921.6 kilohertz. So for the UART, basically what we do, we divide this clock further by 32, which leads to 28 kilohertz or 28.8 kilohertz or 2800 hertz. Okay. So basically, we use this 2800 hertz generation for programming the timer 1. So in the UART, we use timer 1 mode 2. That is actually the mode 2 of the timer is auto reload and 8 bit. Okay. So in the sense, what happens? It is a 8-bit timer. Okay, so you know maximum value what we can have is 1111 1111, right? It is 256. So the timer will start from 0, goes up to 256, and again it returns back to 0. I mean, this 0, right? It can be anything what we program to the timer. In that, when we was explaining timer also, I have shown you. So I can program it something like from 5 to 256. So more the value, this starting value, lesser the overflow time. I mean, if I program 255, for instance, so from 255 to it will become 256, it will be switching. Again, it will reload with 255. It will become 256. Whenever it overflows, one pulse will be generated. That is the basic fundamental concept behind this. So there are some standard baud rate defined by UART standard. Okay. So those standards are 9600, 4800, 2400, 1200. So not only this, it goes up to 11200 also. But right now for 8051, which is of low end microcontroller, let's consider only up to 9600. Like for reload purpose, the value what we have to load to the timer, to achieve 9600, we have to load -3 in decimal to the TH1. Here it will be -6. Here it is -12. Here it is -20. Or in hexa, it is FD, FA, F4, E8. When I say -3, I'm not loading actually -3. It is maximum 255 -3. FF -3. FF -1 is FE. FF -2 is FC, FD, right? So that is what I am loading. It is nothing but, see, the relation is I'm dividing this 28800, right? So 9600 is nothing but 28800 by 3, correct? That is 9600. 28800 by 6 is 4800. 28800 by 12 is 2400. 28800 by 24 is 1200. Okay, that is the value we will load into timer TH1 register. So far, we discussed only one register, that is TH1. Another register for controlling the, that is like if you load TH1, now timer is set, frequency is set at what baud rate we have to operate. Now, with respect to your timer, we have a register called S buffer, serial buffer. This is 8-bit register. So whenever you want to transmit, so we know that like for serial communication, we have TX line and RX line. whenever I want to transmit a data byte, when I say data byte, 8-bit of data, that the data what I am transmitting, I will place in this register, SBUF. In SBUF, I will say. For example, a character A I want to transmit. So for this character A, I know there is a ASCII number corresponding to this A. So that 8-bit value, I will keep it here. So not only during transmission, during reception, whenever the data RX receives, that value will be stored in the SBUF. While transmitting, if I want to send anything, I will push into SBuffer. Whenever I receive something externally, I will read from the SBuffer. So it's a buffer. But actually, as I said, in the UART, we have start bit, stop bit, and parity bit. So this parity start stop, it will be added after this SBuffer. So we need not add anything. We will be placing only pure data. In the receiver end also, your UART hardware will remove the start, stop, and parity bit, and pure 8-bit data will be placed here. So, for example, if I want to transmit a character D, what I will do? I will send move SBUF, comma hash D. I will send like this. So the data will be transferred. So if I am receiving anything, okay, then what I will do? Move A, comma SBUF. If I received anything, the data will be stored in the A now. So we saw two registers, one for timer TH1 for configuring the data rate. Another we saw SBUF, which if I want to transmit any data or receive any data, I will use SBUF data. Third register, what I will be seeing is SCON register, serial control register. So far, whatever the SBUF I have seen, that is again regarding serial communication. Whatever the TH I have seen, that is related to timer for controlling the baud rate. This SCON is again related to serial. This is 8-bit register again, 8-bit register. So here I mentioned we have start bit, stop bit, and parity bit, right? So this register is used to program this, whether I want start bit, or by eliminating start bit, whether I want to transmit the data, whether I want stop bit, or by eliminating the stop bit, shall I send the data. So all these configurations I will put into SCON register. So as I said, SCON is 8-bit. In that MSB bit, that is 7th bit is SM0, 6th bit is SM1, SM2. Also we have read enable, TB8, total 5-bit is over. Then we have RB8, T1, and R1. So address of this SFR is 98H. If you want to directly access this, right, from the memory, that is 98H. So these two, SM0, SM1, right? This specifies which serial mode we are using. This SM2 is used for multiprocessor communication. In the sense, you have to communicate with multiple microcontrollers. Then we use SM2. So this R enable is used as receive enable. So if this R enable is high, then only you will be able to receive the data in the S bus. That we call it as R enable. And EB8 and RB8 is basically kind of reserved bit. We do not use frequently. That is actually not reserved. It is the extra 1-bit transmission, the 9th bit transmission we say, not frequently used. If you want to transmit 9-bit instead of 8-bit, we use. So this last one, TI, not T1, TI and RI, these are the interrupt flags. Transmit interrupt and receive interrupt. So this transmit interrupt will tell you whatever the data you have put into SBUF, whether that buffer data is transmitted successfully. After the stop bit is sent from the UART, right? So this bit will be set. Reception interrupt will tell that you have received 1 byte of data. That too, like once you receive the stop bit, at that point, this receive interrupt will be set. So as we know, we have various modes, right? 0, 0, 0, 1, 1, 0, 1, 1. The general mode what we use, that is 0, 1, first mode. SM0 should be 0, SM1 should be 1. It means we have 8-bit data and 1 start bit, 1 stop bit. That is the general mode what we use. Now let us see what are the various steps for programming this UART. As we seen, like first step, we have to program T mod. Which mode we have to use basically? In mode 2. So we have to write 20H in the T mod register. It means timer in mode 2 and auto reload. It basically helps me to set the baud rate. That is the first register what we saw, T mod register. And next actually, so we had seen TH1. So this, I mean, to set the timer, first we need to set the T mod register. Second step, we had seen this TH1 register. We have to set that TH1 register based on the baud rate. So here we have various baud rates. In that, like whatever the baud rate you want, based on that you will write. For example, you want 4800, then you will write FA to TH1. So third step, we talked about SCON register. You have to write 50H. As I said, 50 means like first should be 5. 5 in the sense this is 0, this is 1, SM2 is 0. Read enable initially let it be 0. So or you can keep always read enable high also. It means 101 is 5. Rest all you can keep it 0, 50 Hz. It is mode 1 of our serial communication. That is third step. Fourth step, set TR1 bit to high so that your timer will start operating. Whatever the timer 1 you have chosen, that will start operating for generating the baud rate. Then use CLR TI, that is this bit you have to clear. That in order to transmit anything, you have to clear, right? Then this step, you write any byte to this F bus. Yes, sir. So what will happen? Whatever the data you have sent, that will write into S bus. Then we have seen that like we cleared this TI flag. Now you monitor this TI flag using jump if no bit kind of instruction, TI. So if there is no bit, I'll be keep jumping here. As soon as this TI is set, it means whatever the data I have put into SBUF, that is transmitted successfully. Then if you want to transmit another byte, repeat this step 5, 6, 7, step 5, 6, 7. Okay, so this is about transmission. So if you want to receive anything, here slight modification, you have to clear RI. Then you have to keep seeing jump if no bit RI. If there is RI, then just transfer to whichever the register you want, that A equals to SCON, SBUF. You have to transfer to that register. That is the step. So we will take some examples to transmit a byte. So we'll write a small program. First stage is move tmod at 20 Hz, move th1. So this basically sets timer to auto reload and timer mode 1, and th1 to hash. Let me consider FA, okay, for 4800. They will ask what frequency you want to configure in the question itself. So let me configure for 4800 FA I will program. And the program statement is you want to transmit character A at the rate of 4800. So then move SCON with hash 50H. So 1 bit stop bit, 1 bit start bit, and 8 bit of data. That is the mode. So then set bit TR1. That means timer started. Your data rate started counting. Then again instead of sending one character, we can send multiple character. Like let me send yes 3 character. Move A comma hash. Directly you can mention the character Y. Okay. Then let me write a small program. Trans. It means transfer. So here what I will do, whatever the value is present in A, I will move into SBUF, comma A. So here I have passed Y, right? And jump if no bit T1. So here I will mention it as a here. So whenever like till the character A is transmitted, that Y is transmitted, it will be keep on waiting here. Once that is transmitted successfully, what I will do, CLR T1. Then I will return. So here I will call a call trans. Same way, move a comma e, then a call trans. Same way, yes also. Okay, yes. Then it will be, and again you can just jump into yes jump again. So what it will do, it keep transferring yes, y e yes. So one by one, character by character, it's a serial communication, right? It will be keep sending character by character. You can also use like, you can take another question, something like as assignment, like you will be transmitting at 1200 only character A. You can take an example like that for you. So as I said, for receiving, you have to make a slight change, right? So what you will be doing, same, here you will write another program called RX. So here initially itself you will be keep waiting, jump if no bit R1. Let me assume here, jump if no bit R1 here. It's not R1, RI. So till that receive interrupt received, I will be keep jumping here. Once I receive, move A comma S buff. So A will be having the received byte. Then again you jump to here. So, but initial steps, right? The configuration of tmod, th1, scon, all these things you have to do in addition to this piece of code for receiving the data. Any questions?
Also from trans, can you repeat?
Sure. So here what I will do, initially I have moved this value y to A, register A, correct? So what I will do, I will move that value to sbuff. Sbuff is nothing but now A is containing this y. So what will happen? I will, so as soon as I pass this A to sbuff, so it will start transmitting bit by bit. It's a serial communication, right? So if A has some value, the extra value, bit by bit, it will keep transmitting. So here what I will do, so I will keep checking this TI flag. TI is nothing but once these bits are completely transmitted, once it's completed transmission, then this TI will become high, saying that the transmission is completed. So what I am doing, so this like till that jump if no bit is like if this TI is 0, it means transmission is not completed. I keep jumping here itself. Once that is transmission is completed, what will happen? TI will become high, right? So then I will clear that and I will return. Again, it will come here. So then what I'll do, I'll update A with E. Now previously I transmitted Y. Now I am transmitting E. And again I will call trans. So A register, accumulator register has E, character E. That I will again put into sbuff. And till the sbuff completes transmission, I will keep waiting here to set this TI. Once this TI is set means that all the E also, E character transmission of E also completed. Then I will clear that TI and I will repeat. I mean, then whole loop will keep repeating. Hope you are able to understand this part. If still not clear,
sir.
you can mention like which part you want me to repeat. Clear, right?
Okay, that's fine. Yes, sir. Clear.
Receive also same. See, that TI and RI plays a major role here. Receive RI flag is actually once you receive complete one byte, then this RI will be set. Okay. So till that RI is set, I'll be keep waiting for reception of data. Once this RI is set means I have the data in SBUF. It means SBUF
Mm.
receive the data. That data I will move into A. It's a reverse
Okay, sir.
concept. That's it.
Okay, sir.